afterwards. Okay, some other stuff we need to ponder. Packaging. Right now, Tor is just a SOX proxy. And you fetch Tor and you fetch Vidalia. It's a little GUI that tells you whether Tor is working. And there's a little Firefox extension called Tor button. And you can fetch all of those, but you sort of have to futz with them to make sure they're working. And I imagine there are a lot of users out there who haven't configured things quite right. Wouldn't it be nice if we could give people pre-configured bundles that do everything the right way? One of the ones we've been working on is a Tor browser bundle. So it comes with Firefox along with all those other ones. And it's pre-configured correctly so Firefox doesn't spread stuff all over your hard drive. And so it doesn't necessarily reveal all the application level worries. And then you can grab this blob and you can stick it on your USB key and you can walk around and connect to the internet cafe. So that's one approach. There are some other approaches that are based on VMs where you're a Windows user and you download this big blob and you run it in VMware. And it's a Linux kernel that comes with a Tor client and a few other things and some IP tables rules that redirect all the stuff into Tor. So this means that rather than saying Tor is a SOX proxy, so I need to configure every application one at a time, it instead just intercepts all the outgoing TCP streams and shoves them through Tor. And that makes it a lot less likely that the user is going to screw up. We've also got a live CD that we're working on so that you don't even have to leave any traces on your local system. You just pop in the CD and you either boot from it through a VM approach or you actually restart the computer and you boot from the live CD. And maybe it runs a Tor client or a server and it's got Firefox and your Pigeon, I guess it's called these days, and whatever other applications you might like. There are some folks in Germany who are working on images for the Linksys WRTG54, the little wireless routers. You can reinstall those with Linux, and you can run a Tor client on those pretty well. And again, it will intercept all the outgoing stuff going out of your wireless connection and shove it into Tor so that it's safe after that. And there's a fellow at Yale who's been working on a Firefox plugin in Java that implements a Tor client. I don't know how far he's gotten. Okay, so there are a bunch of other things that we need to work on. Usability is still a big one. It's been on the list for many years now. Interfaces, installers, making supporting applications like Vidalia and Tor button work better. Windows stability is still an issue. If you run a fast Tor server on a slow, crappy Windows computer, then the Windows computer starts to crash and it all goes bad. So we need to tolerate Microsoft's unique style of networking a little bit better than we do right now. Incentives. Wouldn't it be nice if we could give people better performance if they run a Tor server? So the obvious approach for this, the tit-for-tat approach that BitTorrent uses, is maybe not the right way to do it. Because if I want to attack your traffic, then I'll use you for a long time so that I owe you lots of favors. And then you'll say, okay, I need a fast connection. Who owes me a favor? Roger owes me a favor. I'll connect through him. So at that point, I just bought the ability to watch the first half of your circuit. That's no good. So I'd like some sort of broader or coarser incentive model, and I've got a few that we've been working on, but they're not perfect yet. And then more issues, design for scalability, decentralization. Right now, since every Tor server can connect to every other Tor server, first of all, they're all using lots of file descriptors, because if there are 1,500 servers and they're mostly all connected to each other, then every server out there is using 1,500 file descriptors, which is not good, especially on Windows. So we need some way to maybe make it so that not every server is a link between every other server, or hard to say how to work on that. There are some anonymity questions and some scalability questions there. And then research on anonymity and documentation, user support. We'd love to have your help if you're interested in any of the various pieces I've talked about today. There are some professors here who'd like to work with you on stuff, and we'd be happy to help answer questions and things like that. So I've got, I think, 5.5 minutes for questions. And I'm told you should press the little button on your mic if you have any. Surely there are a few.
How much? Okay. How much does it add to the latency of a packet?
How much does it add to the latency of a packet?
When a packet goes directly from source to destination, as opposed to when it goes through
Yeah, so that's a fine question. The first answer is we don't know because we've been busy building stuff rather than measuring it. But it adds quite a bit. If you're on a university network connection, you will notice it a whole lot. If you're on a modem, you won't notice it that much. So it really depends. Because, I mean, there are two pieces to it. One of them is you're hopping around the world. So the speed of light is going to add latency to that. And the other piece is a lot of the routers are overloaded by all the different streams that people are doing. If you look at 1,000 servers and 200,000 users, that's not a very good ratio. So the second piece of the latency is queuing inside the routers while they're all waiting to be able to send the next packets out. But on the other hand, I mean, there was a study that some folks at Dresden did last year where they showed that the average latency was maybe 3 seconds, I think, something like that. So if you're downloading a web page and you wait 3 seconds to get it, some people find that acceptable, some people don't. Yeah?
Have you tried running like a torrent file on it?
On the network? Have we tried running file sharing stuff on the network? We haven't, but some other users have, and we would rather they didn't. Part of the challenge, so we were talking earlier about the 3 second thing. Part of the challenge, we originally said, I'm pretty sure it'll be self-limiting, because once we get slash dotted, then another 100,000 users will arrive, but they'll all say, man, this sucks, and then they'll leave, and it'll become fast enough that the remaining users will be happy. The problem with that is different classes of users have different tolerance for latency. So the folks who go to sleep with their BitTorrent thing running, they don't care what their latency is, but they're making a lot of web users angry. So there's definitely a challenge here in terms of being able to handle different things. In terms of, CERIAS, I believe, has a configuration option to say, dump everything through Tor. That has led to a wide amount of grief on our part. But actually, they've recently changed it, so you can say, only download the torrent files through Tor, and do the actual data the normal way without Tor. And that's not so bad, because torrent files are a much more reasonable size. So that means you can stay anonymous from the tracker without destroying the whole Tor network. And that seems like a better move at this point. It would be nice to come up with an anonymity system that could handle terabytes and terabytes of data, but we've got a hard enough problem as it is with the one we've got.
Do the countries that have censorship, do
They ban encryption by any chance, or like I'm thinking of the problem of the good Alice who volunteers to help with censorship, or are you forced to use steganography with a huge slowdown?
So most countries that we've talked to, where they have a pretty good internet connection, they don't ban encryption. China, I mean, you're supposed to use SSL to do e-commerce, and they can't ban encryption. That would make a lot of corporations very angry. Iran and other places. I mean, SSL is pretty pervasive, so I haven't found any countries that ban encryption. But there are situations where running a Tor client isn't a very smart move. I was talking to some folks from an Eastern Asian communist country a little while ago, and I was explaining, well, here's how crypto works, and here's this great thing called Tor, and you can be anonymous on the internet. And they were getting phone calls in the audience saying, so-and-so just got arrested, what do we do? And I realized that they needed to learn about operational security, not communication security. And they were telling me some pretty scary stories. Like, when I go to the bathroom, somebody breaks into my house and answers my Skype calls. There's a guy across the street with a parabolic microphone listening to everything I say. They steal my laptop and install new hardware and software on it and give it back. I can't solve that. But there are plenty of countries that really do need Tor from a censorship perspective that aren't that badly off.
no room for steganography?
We sort of have, so there are a lot of different notions of steganography. What we've been working on lately is making Tor's TLS connection, the encryption between, the link encryption, look like web browsing. Our goal is to make the Tor client look like a browser, look like Firefox, and the Tor server look like Apache. And that means that just by watching the bytes going back and forth, you can't say, that SSL handshake looks funny, I'm going to hang up.